Hello everyone, welcome to my YouTube channel Easy Programming. I'm Naveen Mishra and I'll continue teaching you how to write programs in C language and how to think in programming language like C. In my previous videos I have told you about the topics like arrays, pointers, and the last two videos related to the topic of pointers, and I will continue teaching pointers in this video with an important topic called dynamic memory allocations. So let's start with this video. Before starting, I would suggest you guys to watch my previous videos about pointers so that you can understand this topic more easily, and I would like you guys to subscribe and share to my channel. Okay, so let's start. Dynamic memory allocation. First of all, one must know what is static and what is dynamic memory allocation and how they work. So let's start with this static and dynamic memory allocation. Whenever a variable is used in programming, it is allotted some memory space. Definitely when you declare a variable like int a, float b, they will take some memory space in your computer's memory RAM. The memory allocation can be done at two times. One is compile time and another is runtime. The compile time allocation is called static allocation, whereas runtime memory allocation is called dynamic memory allocation. Static memory allocation occurs when you declare a normal variable or an array, like you are saying int a or you are saying int a10. As soon as compiler reads this line, the compiler will allocate some memory space to you guys, or for your program in the computer's memory. The block allotted once to such variables cannot be changed during the program execution. That is, one cannot increase or decrease the memory size. What does that mean is, let's say I have declared an array of int a5. So 5 blocks of 4 bytes each are allotted to your array. Now these blocks cannot be increased or decreased during the whole execution of your program. Okay, this can be problematic as it may lead to wastage of memory space or less memory in some cases. Let's see how it works. Let's see how it happens actually. So first of all, let's study the difference between static memory allocation and dynamic memory allocation. In static, when you declare an array, your memory is allotted at runtime. In dynamic memory allocation, your memory is allocated at runtime. In static memory is allotted at compile time, whereas in dynamic memory allocation, memory is allotted at runtime. Once allotted, your blocks cannot be increased or decreased in the static memory, whereas in dynamic memory, you can do so. When you declare an array, it is a static memory allocation. When you declare a pointer or a linked list, dynamic memory allocation occurs. This is the example how static memory is allocated, and this is how dynamic memory is allocated. Let's start with array. Let's try to understand how array memory allocation works and what is the problem with it. So let's say I have declared an array, example int a5, and placed some values in these indices like a0 equals to 10, 20, 30, 40, 50. As soon as you do this, 5 blocks of memory bytes will be allotted to you in the computer's RAM, starting with the address of 6064, 6,48,700 and 600 to so on. 4 bytes of gap between these, that represents that int takes 4 bytes of memory. Once allotted this memory space, you cannot increase or decrease the size. For example, what if you need more variables, like after this indexes of 4 you want to use 5 and 6. You cannot do this. You cannot increase the size. Okay, and what if you only use 2 variables like a0 and a1? What about the other 3, 2, 3, 4? Will they be free or will they be utilized? Wastage of memory space, as they will take some memory space and no memory utilization will occur. So to overcome this problem, we implement dynamic memory allocation. So it can be very convenient to allocate and deallocate blocks of memory as and when needed. So instead of allocating the memory straight away, when you declare an array, I want to use my memory space only when it is required by me. Okay, so in C, dynamic memory is allocated from the heap using some standard library functions. C language provides you some dynamic memory allocation functions using which you can implement your dynamic memory allocation. So 4 library functions are there, but in order to use them, you must include a header file stdlib.h, stands for standard library.h. Only then you will be able to use the functions. There are 4 functions in stdlib.h that is mainly used: malloc, calloc, free and realloc. Malloc stands for memory allocation, calloc stands for create memory allocation, free is used to free up the memory space, and realloc to reallocation the memory size if you require. So let's start studying these functions one by one. Let's start with malloc function. So malloc stands for memory allocation. It allocates single block of requested memory. What does that mean is, let's say you want 20 bytes of block, so 20 bytes of block will be allocated to it straight away. We'll see it sooner how it works. Now what will be stored in that block that is used by the malloc? Initial value will be garbage, as there is no initialization that will happen in your malloc function. In some cases, maybe there is a possibility that your RAM is totally full and you do not have enough memory space, like 20 bytes is not available for you guys. In such case, memory will not be allocated and malloc function will return a void pointer or a null pointer. Okay, let's see what is the syntax is. So you have to declare a pointer variable first. Then what kind of data type you are using, like integer, character, float, double. Then you will use the malloc function. Inside the brackets you will specify two things: what is how many number of blocks you want to create, and size of data type. What is the size of data type, how many bytes. Okay, you see here int star ptr. So this is a pointer variable which will store the starting address of the block. Malloc will create block of 5 multiplied by size of int. Let's say int is taking 4 bytes of memory, so 5 multiplied by 4 equals to 20, and 20 bytes of block will be allocated as soon as you write this line. And let's say their starting addresses are these, like from 600 to 620, 64,87,600 to 620, and the starting address will be returned to this pointer variable. So your ptr variable will hold a starting address of this block. Okay, so this is a malloc function. I will write a program and implement all this function one by one later in this video. So let's continue studying malloc and then calloc functions. Now there is a very little difference between malloc and calloc. Let's see what it is. Calloc stands for contiguous memory allocation. Okay, it allocates multiple block of requested memory. In the previously used malloc function, 5 into 4 20 block is allocated once, but in calloc function 4 bytes of 5 blocks will be created. Okay, and they will be initialized to 0, whereas in malloc the initial value was garbage, and if for some reasons memory cannot be allocated, it will return a void pointer, same as malloc function. So the syntax is almost same, just you have to change malloc to calloc here. Okay, let's see. So I have used the same example, and instead of malloc I have used calloc. So you see here 5 blocks with each block of 4 byte will be created for you, and the starting address will be returned to the pointer. Whereas in malloc function the only one block was created and its starting address was returned. Okay, so this is the difference between malloc and calloc functions. Now let's try about the realloc functions. Now let's say you have created a memory block of 5 bytes and now you want 6 bytes more, or you want only 2 bytes to be used. Okay, in such case you can use realloc, that is resize allocated memory space. It will only work if you have created a memory space previously using malloc or calloc. For simple array, realloc functions will not work. Okay, so we can use realloc function to resize allocated memory without losing the old data. Plus, when you are increasing your size, your old data will not be deleted. Okay, you see here. So the syntax is almost same. The main difference is malloc is replaced with realloc. This C should not be here, so it is realloc, and one extra parameter is passed to this realloc function, which represents the old pointer. That this is my old pointer, which have, let's say, 5 blocks. Now I want to add 4 more blocks into it here. So this is the old blocks and this is the new blocks that I want to add in this block, and their starting address will be returned back to the pointer variable. Now realloc can create some issues. Let's see what are the issues. Now most of the time you will have memory space available for you, but what if you do not have? So if enough memory space is available at the end of the previous memory block, then realloc will use them and set all the initial value to the garbage. So if you have the memory space, then what it will do is it will create them and will set the all values to garbage. And for some cases, if there is not memory space, it will copy the given code into some other memory space where it can find the space and will add extra spaces that you want to add in the previously allocated memory locations. Let's try to understand it graphically. So let's say I have done this line. So I have created an array. I have created a function malloc and created a block of 5 bytes. And let's say these are the memory addresses of these 5 bytes, 600 to 584. Now I'm using this realloc function. So what I want is I want to switch from 5 to 8. So previously I have 5 spaces. Now I want 8 spaces. So I want to add 3 more spaces. Now there are two possibilities. One is you have sufficient memory available after address 84, and one is not available. So let's see what if we have enough memory space. So after 584, 3 more bytes, 80, 876 and 72 will be created and garbage values will be stored in it. So if you have memory space, this will happen. But what if you do not have memory space after 84 block? So what it will do is it will copy this whole code into some other memory, let's say here. So here the pointer points to the memory address 64,87,600. Now since I do not have any memory space here after 84, I will copy this code into some other memory space, let's say 71,87,600, and copy the whole code here along with some 3 extra bytes will be given to you. Okay, 3 extra blocks will be given to you and garbage values will be initialized to you to them. So there is a possibility of changing the starting address if you do not have enough memory space. So this is your realloc function. Now let's say what is free function. Now once you have allotted your memory using malloc and calloc, the memory will not be freed up by its own. You have to free it using the free function. Okay, so what you have to do, you have to simply say free and pass a pointer using which you have created the memory block. So this function will free up the memory space available to you. Okay, so these are the 4 functions available in dynamic memory allocation. Now I will write a program where I'll implement these these functions. So I am implementing dynamic memory allocation here. I will declare a header file stdio first. I need stdlib.h header file to implement malloc functions and so on. So I'll say include, stdlib.h, and I'll start my main function. First of all, I'll declare an n variable and ask the size from the user. So printf, enter the size of an array. So I'll use scanf ampersand n. Now I will create a pointer variable int star ptr and will allocate memory space of int star. So I'll say int star, use my malloc function here. I'll say n multiply by size of. So this size of function will return int memory size, that is 4 bytes. Multiply the 4 bytes with the size I have given, like 5. 4 and multiply 5 equals to 20, and the starting address of 20 will be stored in the pointer variable. Okay, now I'll say printf, enter the values. Say for I equals to 0, I less than 5, I plus plus. I have to declare the I variable here as well. Printf, enter value for index. So 0th index value will be added, scanf %d, and star ptr. Let's see if it works. I'll say printf /n array values are. I have to use the loop here again, so I'll copy this code and print the values here. index and slash t value star ptr. Save this program. Dynamic. Let's compile this file. There's an error. Invalid type of unary. Okay, just a second. Here so what is the problem here? Okay. The size of the array 5 and the values in array, so 20, and there you go, array values are printed. Now this is a dynamic memory allocation I have done for you guys. Okay, so this is our implementation of malloc function. What if I have to use the calloc function? So I'll simply replace it with calloc. So calloc is there. I'll save some time for me, and we'll copy this code and we'll comment the previous one so that you guys can have the malloc function and calloc functions both here. Previously I think I have done malloc. Let me try. 5, 10, 20, 30, 40, 50. There you go. And let me try the calloc as well. Okay, what is the problem here? Too few arguments to function calloc. So I think I have to done here like this one. Let's see. 5, 10, 20, 30, 40, 50. There you go. It works fine for him. Fine here as well. Just a second. I want to see if there is any problem. Yeah. So in malloc we have to multiply the memory blocks, whereas in calloc you have to pass the two parameters. So calloc is used. Okay. So this is a malloc and calloc functions. Okay. Now what if I have to use the I have to free the memory space? So what I can do is to free the memory space is free ptr, and I'll say printf slash memory is freed using free pointer free function. So let's see if it works. There you go. So memory is free. So free is very easy. You just have to do is call this free function. So this is a free function. Now let's try to do the calloc function. After printing this, I'll say printf enter the new size of the array, and I'll use again the n function here, scan across nd comma and n, and I have to use the malloc function now. So I'll say star ptr equals to int star realloc ptr comma n multiply by size of. I'll use the malloc function, move this, and after allocating I'll simply say ptr, and I'll do the same thing again. I'll copy this code and paste it here. So I have used the new size, new end. I made a mistake here as well, sorry for that. Okay, now let's try to do the program. So let's say I have started with 3 and I do 11, 22, 33. Now, so 11, 22, 33 memory is allocated to you. Now I want new size for 5 and I'll put new values 11, 22, 33, 44, 55 and new memories will be given to you. Okay, so this is the implementation of realloc function as well. So in this program I have implemented all the dynamic memory functions like malloc, calloc, then I have implemented the realloc as well, and then I have implemented the free function as well. So that's it from this video from me. I hope you understood the concept very easily. Thank you very much for watching my video. Please subscribe and share to my channel and like my videos. See you in the next video. Cheers.